I'm glad you don't have to make it like summary.
If you need to write a summary, write it yourself, but I don't make you. I also don't give you points for that stuff. So today's essential question, can I graph rational functions? Yeah, pretty simple. That's it.
Short and sweet.
So we'll do, guys, we'll do two parent functions. Remember, parent function is with no translations on it or coefficients or anything. We'll have two parent functions for this chapter. We'll talk about translations. I said no math. I'm really not teaching any new math necessarily. So we'll deal with A, like as a coefficient, positive and negative. We'll deal with H, which moves my graph left and right, fun away, and we'll deal with K, that moves my graph up and down, right? All that stays the same. So when we graph f of x equals 1 over x, and that's a rational function, right? You see my x is in the denominator. Nothing changes. What do I always start with when I graph? What?
No, X, Y,
I start with a chart, right? X and Y. All right. I'm going to start with pretty easy numbers. I'm going to do -2, -1, 0, 1, and 2. And then I'm just going to plug them in. So let's plug them in. So y equals, let's start with -2. So y equals 1 over, and I'm taking x and replacing it with -2. So -1/2. Good turn. How about -1? If I plug in -1 for x, that's 1 over -1, which is -1. How about 0? What happens when I divide any number by a 0? No, it's not 0. I heard it. It's undefined. It'll give you an error in your calculator, guys. A number over 0 isn't 0.
Oh, yeah, that's it.
A number over 0 is not a number. You can't divide by 0. It's against the rules of nature. Right? So all you're going to write when you divide by 0 is undefined. And we're used to just doing UND, right? For abbreviation. Huh? Yeah, I want you to put undefined, because that's an actual like math term definition. NA, that means not applicable, right? So that's not actually correct. So it is undefined. Okay, so I can't have an answer or an x of 0. No. So if I plug in 1, just positive 1. 1 over 1 is, guys, is 1. And if I plug in 2, 1 over 2 is just 1/2. So if we go to graph this, all right, so start with -2 and -1/2 right there. -1 and -1. Okay, 0 and undefined. When you get a value of undefined, what do you think you're going to put there? Not nothing.
I mean,
I'm not going to mark a point.
Did you put it on 0?
This is on 0. What did I draw? What did I have on graphs that I could get really close to a value, but I can never actually have an asymptote? When you get an undefined value, guys, that is an asymptote. So if I plug in 0 for x, I get an undefined, not even an undefined answer, I get an undefined value, right? That means I can't plug in 0 for x. It isn't a value I can use, meaning I have a vertical asymptote at x equals 0 on the y-axis. So I can't have x equals 0. So I'm going to put a vertical asymptote there. All right, next I've got 1 and 1, 1 and 1, and 2 and 1/2. Okay, right? Good. So that's weird, right? Yeah. What type of line is that? I don't know. Okay. Let's graph a couple more. All right. Let's throw a couple more in there. I could keep going. Bigger numbers. I got 1 and 1, 2 and 1/2. If I plug in 3, I'm going to get a small number, right? So let's go the other way. Instead of 2 and 1, let's get real close to my undefined 0. So let's do 1/2 and -1/2. So 1/2 and, I don't know what I'm doing. 1/2 and -1/2. Okay? So if I plug in 1/2 for x, that's y equals 1/1/2. And when I'm dividing by a fraction, what can I do with that? Do what? 2, how'd you get that?
Because 1/0.5 equals 2.
Yeah, 1/0.5 equals 2. You can do that. Or, guys, you can think of this as 1/1, right, times 2/1. When I'm dividing by a fraction, that is the exact same as multiplying by the reciprocal.
Yay.
So 1 times 2 is just 2. If I plug in -1/2 and make this negative, I just get an answer of -2, right? All right, so keep going. So now we've got my x of 1/2 and 2, and -1/2 and -2. All right, that's a little better. You see those little elbows starting to go here? I've got a little elbow there. Here's the deal. I can't connect these because of that asymptote. So these lines, wow, that's terrible. Hold on, that was awful.
I'm sorry, that was not a good one.
Done.
You know what? Who's trying? Yay, wait. You know, come get there.
Do.
I think
Hold
it's
on.
4. No.
So those, I can't cross this vertical asymptote here. And as I get more negative up to or near to 0, I'm going to get bigger and bigger numbers. Same coming this way, right? So those are my parent functions. I have that vertical asymptote at x equals 0. Are there any other asymptotes here? Y equals 0. So kind of just looking at it, we can see, well, it kind of looks like there's an asymptote here, right? Like it looks, and I don't like this, so we're going to say why there's an asymptote there. But it looks like there's an asymptote at y equals 0. Let's think about that. Is there any number I can plug in for x, where after I do 1 over that number will get me 0? I mean, there's no number. I can't use 0 because that's undefined. You can plug in a million, right? If I plug in a million for x, that's 1 million. 1 over a million, right? I can plug in 50 billion, and it's 1 over 50 billion. That's a tiny number, but it's not 0. So there's no number I can plug in for x that's going to get me 0. So for rational functions, you guys, you are always going to have 2 asymptotes. One horizontal and one vertical. They're always going to cross. They won't always cross at the origin. We'll talk about how they move around next. Well, not next, but later in today. Right? But you're always going to have horizontal and vertical asymptotes. So I have a horizontal asymptote here. It is at y equals 0, right? I also have a vertical asymptote. It's at x equals 0. So domain and range for this. Domain. Can I go all numbers go into negative infinity? Doesn't that arrow go towards negative infinity? Okay.
Which 0? Y or X?
I don't know. Guys, what's the only number x can't equal? 0. Can I have all numbers greater than 0?
Yes.
Yeah.
Can I have all numbers less than 0? I just can't equal 0. So when you're writing your domain and range for these problems, x cannot equal 0. That little equal sign with the slash through it, that means exactly what you think it does. You can't equal 0. Well, that's for domain, right? Let's think about range. So for y, what number can't I have for y? 0, right? There's no number I can plug in for x that will give me a 0. So y cannot equal 0. Make sense?
Sure.
That's your parent function for 1 over x. We'll throw in h, k, and a in a minute. First, I want to do my parent function for 1 over x squared. Okay? So here it is, 1 over x squared. Stays the same. What's my first step? T chart with x and y. Plugging the same numbers, -2, -1, 0, 1, 2. All right, let's go ahead. plug in -2. So 1 over -2 squared. Well, what's -2 squared? What's -2 squared? Well, -2 squared is 1/4?
Yeah.
-2 squared?
It's negative. It's 4.
Yeah, thank you, it's 4. I'm not asking you what, you're skipping ahead of me, trying. So,
Wait.
y
did you
equals,
make -2 to a fraction?
1 over -2 squared, right?
I don't know.
What is -2 squared, Trent? 4. -2 times -2 is 4. So 1 over 4 is 1/4. Yeah, you guys skipped ahead of me. So 1/4. -1. What's -1 squared? Just 1. So 1 over 1 is 1. All right. 0. What is 0 squared? 0. Meaning I still have a 0 in the denominator, meaning the value for 0 is undefined again, right? So I'm going to say let's stop right there, where I get an undefined value, and draw my asymptote. So where am I going to draw it? Actually, where am I going to draw my asymptote? Down the y, what?
I don't know, but like axis.
The y-axis, right, where x equals 0, right?
I'm sorry, I knew it was.
No. It is for my parent functions. I talked about how we'll translate later my asymptote. It's the function, so nice and easy. Good, so that's awesome. So I already know my vertical asymptote, right? So Ashton, plug in 1.
Yeah.
What do you get? 1, right, so 1 squared is 1. 1 over 1 is 1. Good. How about 2?
That's a big math right there.
Colton, what do you get for 2?
Come on, you got this. 4. 1 over 4.
1/4. Good. Guys, what do you notice is different, besides like getting different numbers? What do you notice about my y values?
Same.
They're the same. There's no negatives.
Same.
Why don't I have any negative answers? I plugged in negative numbers because I squared. Square's always going to give me positive numbers, right? So when I go to graph this, I already got my undefined. -2 and 1/4. -1 and 1. 1 and 1. And 2 and 1/4. Again, not very useful in terms of graphing, is it? Let's plug in some more. Let's do -3 and 3. So plugging in -3, what do you get? 1/9. And plugging in 3, what do you get? 1/9. Good. You see the pattern? That's awesome. So 3 and 1/9 and -3 and 1/9. Now, how did Mr. Jackson know not to touch that x-axis there? I have another asymptote there, guys. I told you we're going to have vertical and horizontal for each of them. How do I know it's at the x-axis? I am literally the smartest person in the world, so that makes sense that I know it. Just because I'm squaring the number, does that change the fact that I'll never be able to plug in a number for x that will give me a value of 0? No, it's always going to be 1 over some number, right? Yeah. Some number between the smallest number ever and the biggest number. But it's going to be a number that is defined, right? So I'm always going to have a number. So I can't have values of 0. Yes?
Both the asymptotes be the same, like both sides make that.
No. I'll show you what they'll move. They'll translate just like we did with logarithmic, with radical functions, with exponential functions. They'll move. We'll get to that. So, but it's very easy. So. Good. So I have a horizontal asymptote at y equals 0. I have a vertical asymptote at x equals 0. So the domain for this function, I can have all numbers less than 0 and all numbers greater than 0, but I can't have 0. So x cannot equal 0. Range. Well, we know there's at least one number I can't equal. I can't have 0, right? What other numbers can I have?
Negatives.
Nothing negative, right? Since I'm squaring, I can't have any numbers negative. So the easiest way, you could write that x can't equal 0, and also y can't equal 0, and also y has to be positive numbers. Or I could kill two birds with one stone. So I kill birds with stones.
I have.
It's really awful.
Just kidding.
Y has to be greater than 0, right? That's my way of saying it has to be all positive numbers, and it can't be equal to 0. So if you want, guys, I won't take off if you write this in a different way as long as you cover all your bases. But the easiest way to write this is just one little y has to be greater than 0, right? What do you mean it doesn't matter what it is? Well, that'd be true, but you can do that, but you also have to tell me that y can't be negative. Because this just tells me that it can't equal 0. I can have negative x's, right? I just can't have a 0. For y, like I can't even have negative numbers. So you can say y can't equal 0, but also y needs some positive numbers, and the easiest way to do that is y squared. All right, translations. Guys, two ways we're going to do translations. My entire, the big long way of writing out my functions for rational functions is going to have a, h, and k, I said. So if I write that out, it's y equals a over x plus or minus h. So there's my a, there's my h, plus or minus k. So at negative a, we'll do two things. So a will flip. If it's negative, right?
Yes, sir.
So just the presence of having a, like if it's 2 over x or 3 over x, doesn't mean, take notes, doesn't mean that I'm flipped over the x-axis. It's only when it's negative that it's flipped over the x-axis. The other thing it will do, it will stretch or shrink the growth of y. If I have answers bigger, or if I have an a value bigger than 1, so if I have like 3 over x or 10 over x, do you think that shrinks or stretches my graph? Stretches. It's a bigger number. As a gets bigger, it stretches my graph vertically. If I have numbers smaller than 1, I will shrink. So, for a here, g of x equals negative 2 over x. Compare the given function to the graph of f of x equals 1 over x. 1 over x is my parent function. So this thing, my a here of negative 2, does two things, right? One, it flips it. So this guy is, and you can just do bullet points. So flips over x-axis. What else does it do? It stretches it vertically. For b, I have 0.25 over x. What will a do to this graph? A is 1. What is in this equation? 0.25. So what is it going to do? Shrink. Anything else? No, that's it, right? It's a positive number, so it's not going to flip me, and that's all a can do. Flip if it's negative, and it'll stretch or shrink. What? And this one will shrink. I'm not super worried about stretch or shrink, guys. My main concern is flipping. Yeah, I don't grade you really on graphing, at least in quality, as long as you get close. So stretch and shrink, not a big concern of mine. But flipping, that's right or wrong, right? No, anything where I'm really concerned about you. Well, and anything I'm having a graph where I'm worried about the stretching and shrinking is going to be make a chart and actually graph it, so you'll have points to keep you from stretching and shrinking, right? So that's where you'll get that flipping. Cool.
So anything that's less than 1 is a shrink, and anything greater than 1 is a
Stretch.
okay. So
Okay.
both of them were shrinks.
No. This was negative. Oh, one because negative 2 is technically less than 1. Absolute value. So 2 is bigger than 1, right? So this will flip because it's negative,
Yeah.
but then 2 will make it grow. Stretch, right? Makes sense?
Yep.
Sorry, I said that weird.
You're fine.
So, graph the function. State the domain, range, and asymptotes. You will have 2 asymptotes, Ashton. We got go. Some notes, next page. Ashton, first step, anytime I graph, X and Y. So, guys, remember when we did radical functions? So I had y equals like the square root of x. Sometimes I would have to change the numbers I plug in, right? I'd start with like -2, -1, 0, 1, and 2. Remember that? And then I would change those numbers that I plugged in. What did I look at in order to change those numbers? What value? Or what part of my equation? The what? There was a number within the square root that I looked at. Anybody? No? So up here, I had y equals a over x plus or minus h plus or minus k, right? I looked at h. So what did I do with h in order to change my numbers? Yeah, but how did I know how to get in the purpose field? That is what I want. You're right. What? How did you know? Well, no. Oh, sorry. Yeah, my bad. No, you're good. How did you know to subtract 1? Good. So what is h in this equation in n?
No.
Right. Change the sign on it. It's -1, right? So this is x plus 1. So change the sign on h. So what am I going to do to -2? Subtract 1, and so instead of plugging in -2, I'm going to plug in -3, and -2, and -1, and 0, and 1, right? When we get down to squared, when we do -3 over x plus 4 squared plus 1, do you think you do anything different? Or what do you think you'll do to each of your numbers that you plug in? Subtract 4.
What? Oh, what?
Oh, sorry, I was looking at it.
You were looking at the other one.
Why do I just?
Because it's x plus 4. I'm not worried about that square. So we'll get to that later. Good. So let's do this. Let's plug in -3. So y equals 2 over -3 plus 1 plus 3. So what's -3 plus 1? -2. What's 2 over -2? Yeah, that's -1, right? 2 over -2. Victoria? What's that reduced to?
I can't read it.
Okay, maybe we'll move up closer.
Well, don't have my contacts in. I can't read.
Okay,
Then
well,
maybe you don't like me.
then do me a favor.
What is this?
Plug in -3. This reduces down to -1 plus 3, which is right. Alright, plug in -2. So if I just change this now, this is now -2 plus 1. So what's -2 plus 1?
5.
-1. What's 2 over -1? 2 over -1?
-2.
-2, right? -2 plus 3.
Alright.
Good, yeah, you're right.
Wait,
Good, so what happens when I plug in -1?
here's 0.
Good, yeah, so -1 plus 1 is 0. So this point here still gives me what value?
Undefined.
Undefined. What? It doesn't matter. So if I get undefined, right? So 2 over 0 is undefined. It doesn't matter that I'm adding 3. What is undefined plus 3? Still undefined, right? So guys, you stop right there. That's what I'm saying. As soon as you get an undefined value, regardless of the fact that this says plus 3, or that this says plus 1, because you can't add 3 to an undefined value. You can't add 1 to an undefined value. As soon as you get undefined, stop and draw your asymptote. So you're asking me, when will my asymptote move away from the zeros for my axes? Where does this asymptote move to?
-1.
What equals -1? Yeah, x equals -1. So when I plug in -1 for x, I get undefined. That means I can't have -1 as an x value. I'm going to go ahead. I'm not even done with the problem. I'm going to write, I have a vertical asymptote at x equals -1. Then I'll change back to blacking and keep working. Plug in 0. What's 0 plus 1? 1. 2 over 1 is 2, and plus 3 is 5. Do 1. 1 plus 1 is 2. 2 over 2 is 1. Plus 3 is 2 over 2 is 1 plus 3 is 4, right?
Yeah.
Okay. I can already tell, guys, this probably isn't going to be enough in terms of my drawing. So let's keep going. Let's add a -4, because that's my next -1, and let's add 2. Okay? -4 plus 1?
3.
-3, and 2 over -3 is -2/3. And this might be a calculated thing. So -2/3 plus 3?
2 and 1/3.
2 and 1/3. Good. If you wanted to change that to 2.33, that'd be fine. And then 2 plus 1 is 3. So 2 over 3 plus 3, it's just 3 and 2/3. Right? So then we go and graph. I've got a -3 and 2, and -2 and 1. My undefined, I've got 0 and 5. 1, 2, 3, 4, 5. 1 and 4. I've got a -4 and 2 and 2/3. And I've got a 2 and 3 and 2/3. I can't read this. 1, 2, 1, 2, 3. Okay. So that gives me a little bit of a better idea. Now, I drew that with, it looks like another asymptote, right? I told you we'll always have 2. Where does that asymptote look like it is?
3, 1.
At 3. It is at 3. How do I know that's at 3?
Because your little graphic thing at 3.
Okay.
Plotting at 3.
Yeah, I like that you can look at that and say, hey, that looks like it's an asymptote. That is a good skill to have. But I want us to know exactly why it's at 3. And now Trent thinks he knows why it's at 3. I know you know how it's right.
Right. Yeah, because plus 3.
Good.
Okay.
I've underlined it in blue, right?
Yeah.
Good. So that stays the same, guys. You changed the sign on H, right? And we did that, and so it was +1, but H becomes -1. So that moves my vertical guy to the left one. But then my K value is +3, meaning my horizontal asymptote has moved from 0 to +3. So I have a horizontal asymptote at y equals 3. So this question didn't ask you hey, how does this compare to the original graph? But you could tell me it's moved to the left 1 and up 3. You don't have to, it's not a requirement, but that's what you could have told me just by looking at, hey, I've got a +1 there, +3 there, so I'm going to change the sign and move back 1 and up 3. Good, so domain and range on these guys. Domain. What do you think for domain?
I think your domain is in the front.
No, I can have 0 numbers for x. Nothing. No values for x at all.
I mean, you probably could.
What about all these numbers?
All the numbers?
It's not all real numbers. What can't x equal?
3.
-1, right? I moved. It was 0.
X cannot equal.
Yeah, so x
I knew it.
cannot equal -1. Guys, just look at your asymptotes. You'll change that to a not equals or sometimes to a greater than, less than, right? Okay, so for range, Holden's got his hand up.
Is x always gonna equal or not equal? Is x always not gonna equal your vertical asymptote?
Actually, x will, yeah.
I think that's sure. Change your shirt really
I like tested it.
Are you good?
Custom made.
What is that? What is that?
Straight out of the
Oh, that's cool. I like that.
Like what?
Shut up, come on. Crazy ass person. Right.
Good. Range, Colton.
Y is greater than 3? No.
It can be. So you're half right. What can y also do? It can be greater than 3, right? So here's 3. It can definitely be greater. Can it also be less than 3?
Yeah, so.
But what can it not equal? Look at your asymptote.
It's -1. No, it's 3.
3, right? Y cannot equal 3. All else fails, guys. Just start down here and go for y and moving up. Am I good? Am I good? Yes, I'm good. I'm good. I'm good. I'm good. Nope, I can't equal that. But then I'm good. Everything above it. Right? So stop and look at this. Guys, my parent function for this, f of x equals 1 over x squared, right? That's my parent function. Think about how that looked. So right there, and goofy guy that was all positive. That was my parent function. So then when I get an a value of -3, what should happen to it? It should flip across the x-axis. Is it? Yes. Okay. And then I have a k value of +1, so it's moved up 1, and an h of -4, it's moved back 4. Right? So when in doubt, kind of sketch your guys. When in doubt, kind of sketch your parent function. Okay. So there it is, and go. All right, I'm flipped, and I'm moved back here. That's how you check this.